Right, take two of this video for your lesson today. I'm so sorry for this being late, year 13. I am in fact a complete idiot. Anyway, I was going to moan on about what I had done wrong there, but actually you'll not care, so it doesn't matter. So let's look through these questions. Just to add to my stress, I had intended on going through and marking yours before this lesson, and I haven't been able to. I haven't had the chance to. I'm really sorry. I am still intending on doing it during this lesson, but now that's going to be delayed even further because of my own stupidity. Right. Anyway, so these past paper questions from Friday there. Question 1. So we've got a velocity time graph for a car travelling along in a straight line along a level road, and we have to talk about the acceleration or the deceleration, and we need to use words like uniform, non-uniform, zero, acceleration, deceleration. We're describing the motion between these time intervals. So from time of 0 to t1, if you look at the graph there, it is a curve. So that is a non-uniform acceleration, and we know it's accelerating because the magnitude of the velocity has increased. Oh, I can hear myself talking really fast here. I'm rushing because I'm stressing out. I'm sorry. Right. Time t1 to t2 is a flat horizontal line, so that is zero acceleration. Now see here, I wouldn't put constant velocity in there because the question has specifically asked us to talk about the acceleration. T2 to t3 is a linear deceleration, but they haven't asked us to use linear, so uniform deceleration, and we know that because the magnitude of the velocity is decreasing, and it's a straight line. Okay, next question. I'll try and calm down a wee bit now. Right, question 2. So a catapult is used to project a ball vertically upwards with an initial velocity of 5 meters per second to calculate the maximum height reached by the ball. So here's my UVAST. I noticed actually just as I was finishing recording this last time with no sound, my units throughout this are horrendous. I apologise. Do as I say, not as I do, so put units on your stuff please. So I have taken up the way as being positive here, right? Should have actually written that down. And it's fired up with an initial velocity of 5 meters per second up the way, because see the way this is asking us to get the maximum height. At the maximum height, the velocity is going to be 0. So it's always a good wee way to get an extra bit of information in here. Acceleration is going to be down the way because it's due to gravity. So that's minus 9.81. And we're being asked for the displacement here, the height. So we're looking for S. So we've got UVA and we're looking for S. We need to think what equation of motion links those. V squared equals U squared plus 2AS. Hopefully you can see there my values substituted in just from this. Rearrange and you end up getting 1.27 meters. Now, for part 2, calculate the total time, the total flight time from the launch until it returns to the starting point. So, see what I have done here. You can see I'm just reminding myself because this is such an easy place for silly mistakes to happen. So, the time taken to go up to the top is going to be half of the total time because it's going to take the exact same amount of time to come back down again. So the time to the top means that we can still use this little list of information here. We can put in V as 0, put in the rest of our information, and we get a time of 0.51. Then we need to double it to get the total time of the flight. So that's all I've done there. I've multiplied by 2 to get 1.02 seconds. Right, part B is very similar to that first question. So we've got a velocity time graph for a car going along a straight road between two sets of traffic lights. So time of T0 is one traffic light, and then I can't see it, it's so tiny, T3 must be on, no, T4 on is the final traffic light. Oh, I can't get my words out, right? So describe in words how the acceleration of the car varies in the following time intervals. So from T1 to T2, that's that second little section of the graph, the velocity is increasing at a linear rate, so it's a constant acceleration. T2 to T3 is a flat horizontal line, so time's continuing on, velocity staying the same. So it's either constant velocity or 0 acceleration. I would prefer to put the 0 acceleration in here. just because the question specified acceleration. But I think in this one they would have accepted the constant velocity there. Okay, right, T3 to T4 is that last little bit. So the velocity is decreasing. It's a nice straight line, so it's doing that at a linear rate. So it is a constant deceleration or uniform deceleration or linear deceleration. Then part 2, state how the distance between the traffic lights could be deduced from figure 2.1. So I was about to say there, you don't actually have to calculate it, but sure you can't. They haven't given you any values anyway. So you just have to say how you would do that. But look, they're like very specific about it. So first of all, you say the distance is the area under the graph. But to get the second mark there, you had to say from time t is 0 to time of t4. I'm not convinced I would have thought to put that level of detail in there, if I'm honest. But there you go. Right, question 3 is probably the most awkward one in the whole set. So let's have a proper look at the question here. I have not figured out how I can get my mouse to point at things on the screen here. I feel like I used to be able to do it and now I can't, and I thought I was doing the same thing. So there's going to be a lot of this going on. Okay. Right, anyway, a ball bearing is propelled up a 3 meter long frictionless ramp. It's released with an initial velocity of 3.6, and you can see all that on the, there's no point me trying to point, you can see all that on the wee diagram there. At a point 1.4 meters from the foot of the ramp, and it tells you the foot of the ramp is 0.00 meters. It reaches a maximum distance of 2.6 meters from the foot of the ramp here. Part 1 show that the deceleration of the ball bearing is 5.4 meters per second squared. Now, do not let the fact that this ramp is at an angle throw you off. I honestly think that's the only reason that it is at an angle, to try and catch you out. There's no need for it to. If you just think everything through logically, you will be fine. So let's have a little look. Okay, try not to show you too many answers at the same time here. But what was this? Get the acceleration to be 5.4. So I've taken going up the ramp as being positive, right? So 3.60. If we're going up until that the maximum height it reaches, then velocity is going to be 0. This question is actually very similar to something getting thrown up and caught again, just that the acceleration isn't due to gravity. It's because of this ramp here. Anyway, acceleration is what we're looking for. The displacement, be super careful, because if you do this in a rush, you'll miss this out. The displacement, it goes from that starting time until it stops, is the difference between those two wee markers. So it started at 1.4 and it reached 2.6. So the displacement is 1.2. I think if you were doing that in a rush, you could very easily accidentally put 2.6 in there. So just watch out for that. So we've got u, v and s, and we're looking for a. So what links those? V squared equals u squared plus 2as. Substitute in your values, do all your rearranging, and you end up getting 5.40. Right. The next wee part 2, is calculate the distance of the ball bearing from the foot of the ramp after 1.6 seconds. So here's my working for it. Okay. We'll get my u vast in there. So I've marked on here, I'm taking going up the ramp as being positive. So u is 3.6 up the way. V, we cannot have a 0 anymore, because the velocity isn't 0, 1.6 seconds. Well, we don't know if it is or not, but we have to assume it's not. Acceleration, we do now know. Now, the ball bearing, is this a ball bearing? Doesn't matter. Yeah, it is. It's going up the ramp. The acceleration is always going to be going down the ramp, so that's why it's minus 5.4. Be super careful with that. Displacement is what we're looking for, and the time is 1.6. So we've got u, a, and t, and we're looking for s. So s equals ut plus a half at squared. Fill in the values from over here. Oh, sorry. Fill in these values here, and you end up getting minus 1.15. So that means that the displacement is 1.15 meters below or down the ramp from where it started. And this question had asked from the foot of the ramp. So because it started 1.4 meters up the ramp, then we just need to go 1.15 meters down from that. So take that away from 1.4 and you get 0.25 meters from the bottom of the ramp. Now, part B, is asking you to sketch a velocity time graph during the first 1.6 seconds. So my first thought was, right, well, I don't know what its speed is at 1.6 seconds. So that was the first thing I did. I used this UVAS list with U of 3.6, A minus 5.4, and then time 1.6 to figure out what its velocity is going to be after 1.6 seconds. That gets you minus 5.04. The minus just means it's going down as opposed to this 3.6, which was when it was going up. Okay. So here's my graph, and do you remember I was saying there that this question is very similar to a ball being thrown up and caught again. It's just been put in a different context. This, I think, shows it. Throughout this whole question, the deceleration is, I've forgotten already, 5.4. So it's going to be a straight line. The velocity is changing uniformly, and it's doing so at a rate of 5.4 meters per second squared. So I put my graph like this. I said, right, it started at 3.6 going up. I'm taking up the ramp as being positive in this one as well. This here is whenever it reached its maximum height and it had decelerated. So this is it going up, decelerating, decelerating, decelerating until it reached its maximum height. And then it accelerates down, and it does that at the same rate, which is why our graph is the same gradient. And then after 1.6 seconds, it's at 5.04 meters per second the other way. Now, your graph may be a mirror image of this. So that's absolutely fine, as long as, like, if you started at minus 3.6, then at 1.6, make sure your velocity is at positive 5.04 then. I'll show you a quick look what the mark scheme said. Well, I tell a lie. The mark scheme was actually way more detailed than this, but I, simplified it a wee bit for myself for looking at your stuff, which I still haven't done. So one mark was for the graph shape, and then I put in there, or it could be starting at minus 3.6. So for this shape, like the constant gradient, or the mirror image of what I've drawn here, will get you that first mark. The second mark is for having the final velocity's magnitude greater than the initial velocity. So they didn't even need you to have that 5.04 marked on. Sometimes they do though, so just be careful. The reason that's there, I reckon, is because I think a lot of people will automatically just go from 3.6 to minus 3.6. They'll not think it through properly. So just be careful with that. Okay, last question. Right, I'm apologising in advance here. I was determined to get this on two sides of a page, and I've squashed my working for this one a wee bit. So, a new sports car is to be tested on a long, straight, horizontal test track. The test driver starts the vehicle from rest, accelerates uniformly to a maximum velocity of 200 kilometers per hour in 12 seconds. Car continues at this velocity for 20 seconds before the brakes are applied, causing constant rapid deceleration. Car comes to rest in a further 8 seconds. All that information we don't actually need until the next part of the question. So part 1, show that 200 kilometers per hour is equivalent to 55.6 meters per second. Now, I did my working out for this here like kind of opposite of the way I normally do. I don't know why. But this time I was like, right, well, 200 kilometers per hour. If I divide by 60, that's going to give me how many kilometers it goes in a minute. Divide by 60 again is going to give me how many kilometers it goes in a second. Now, this here type of working out really is the only time that I keep units on throughout my working out, because it helps me keep track of what's going on. Then to go from that to how many meters it is per second, multiply by 1,000. Normally I just do the meters bit first and the time bit second. Don't know why I did it the other way around. But anyway, that gets you 55.6. Now, part 2. Sketch a velocity time graph to represent the motion of the car on the track and include relevant numerical data on both axes. So, do you know what I did, which I don't think it was a bit of a waste of time? I don't know. As I went back now and reread the question and made a wee UVAS list, but this is only really for the first wee section, so I didn't actually use it that much. The test driver starts the vehicle from rest and accelerates to a maximum velocity of 200 kilometers per hour, which we've just figured out is 55.6 meters per second in 12 seconds. So that's this little bit of the graph. So I didn't actually really need to make this list. So it goes from 0 at 12 seconds, it's at 55.6. And because they said it accelerates uniformly, that's how we know it's a nice straight line. The car continues at this velocity for 20 seconds, so that takes us until a time of 32. Nice constant velocity before the brakes are applied, causing constant rapid deceleration. Constant again, straight line. Car comes to rest in a further 8 seconds, so at a time of 40, we're back to 0 again. Then the very last little part, this is the bit that I've squashed in far too much. I'd be raging if one of you did this and then look at me doing it right. Use your graph to find the total distance the car has travelled during this test run. Well, that's just going to be the area under the graph. So that's what I've written there. Distance is the area under the graph. I've split this into 3 sections. Area 1 is a triangle, so a half times base times height, half times 12 times 55.6. Area 2 is a rectangle, so 20 multiplied by 55.6. And then area 3 is a triangle, half times base times height, so half times 8 times 55.6. And we end up getting 1668 meters. Okay, in my frantic rush, I've forgotten to give you retrieval roulette questions there. I think I might, I'll just leave it for today. Now, here's the other thing. None of you told me about those like the textbook questions that were in your notes. You never told me if you wanted me to go over any of those ones. So please, 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 please let me know if you do. Make sure that you do your corrections for these. And then we will actually, I thought we were starting projectiles this week, but we're not going to because you've got no classes on Thursday. So we'll start projectiles next week. Okay, that is us, I think. Right, let me hurry up and upload this. Bye.